Like, are you doing self-care? Julian, is your phone put away? Are you going to sleep in time? Are you eating 3 meals? Do you have snacks? Are you drinking water? Are you getting stuck on social media? Did you delete TikTok? One of my students in my GLS class deleted TikTok because he said that is a good thing for him. Okay. So, folks, like, yes, there's a lot to do now, but the big but is you are responsible for your well being as well. And if you're overwhelmed, but you're on, like, you're watching TV or you're going out with friends or you're on social media, sorry, like, that's not right. That's not how you do it. Right? If you're like chatting with friends, like, oh my God, I'm so stressed. There's so much work. Yeah. But like not actually doing it. Right? So please take a step back, think to yourself, am I taking care of myself? Am I prioritizing what needs to be prioritized right now? That might mean not going out with your friends after school. And yeah, that sucks. But you know what? That's what you have to do right now. Yeah.
Aren't you supposed to balance all portions of your life, so like social and school?
Absolutely. However, there are times that you're not going to be balanced. And also, do you see your friends after you do your homework? Do you go on social media after you do your homework? Or do you leave homework till 9 o'clock? Okay. So sometimes one of the best,
Yeah, I'm gonna get home at like 7.
because you're hanging out
No, because I go to the gym.
for 5 hours.
Yeah. Well, it takes really long to get home.
So you need, all I'm saying is everyone's got different priorities and different situations. So just imagine you are a 30-year-old. Okay. Imagine, Liam, that you're the, what would 30-year-old Liam tell you right now? And follow that advice. Okay. You don't have to say it. That's what I mean. Like, I'm just saying sometimes we have to adjust. All right, folks, let's get to the lesson. So today is the second day of the inverse function. And I'm going to ask everyone to settle in. Stop your conversations, please. Excellent. Going through the learning goals, I realized that this last one is not one that we're going to do. So let's cross it out because it talks about inverses as word problems, which is fun, but we're not going to look at it. All right? So today what we're going to do is address the question that team would have had. And it was this. Well, if my original function is a parabola, my inverse is not a function. Agreed?
Yeah.
That's a problem because this course is called functions. So let's see how we can address that. So the first thing we're going to do is we're going to graph the inverse of a function and to determine whether the inverse is a function or not. So that's the first thing. Is the inverse a function? Step 2, we're going to restrict the domain of the original function. I'm going to say that again because it's kind of tricky. What we're going to do, we're going to restrict. We're going to put some boundaries on we're going to restrict the domain of the original function so that the inverse can also be a function. So instead of like getting an inverse and being like, it's not a function, we're going to think ahead and be like, oh, I know the inverse won't be a function. So I'm going to do something to my original function. Okay. Let's start off by graphing our function f of x equals x squared, and then graphing the inverse of that function just by switching the x's and y's. So what we're going to do is for f of x equals x squared, I'll make a table of y's and x's, a table of values. Okay, there are absolutely no transformations. So if x is 0, y is 0, x is 1, y is 1, because all we're doing is we're squaring the x. Astrid, can you see? Sebastian, can you see? Anyone not able to see the board? Okay. If x is 2, y is 4. Let's put some negatives in there. Well, what if x is negative 1? What's y? Positive 1. If x is negative 2, y is positive 4. Great. Okay. And now, before we graph it, we're actually going to figure out the coordinates of the inverse just by using that magic trick that we know, which is to literally swap. Okay, it's to swap the coordinates. So 0, 0 doesn't matter. 1, 1 doesn't matter. But 2, 4, they switch up, right? 4, 2. Negative 1, 1 becomes 1, negative 1. Negative 2, 4 becomes 4, negative 2. Right? Pause, make sure you know what we're doing. Ask me a question. Yes?
Squaring the x on the left side, how come the y is getting double?
Are we talking about the pink?
Yeah.
So if you take an x of negative 2 and just square it, that'll negative 2 times negative 2 is positive 4. Great. And so folks, in this unit, because we're putting multiple graphs on a table, it might be useful to have colors, right? So if you have colors, take them out. Yeah.
Why is the f for the blue? Why does it say f and then the little negative 1x but no x squared?
Like nothing here.
Yeah.
I just didn't write the equation, but I'm like, by writing this means inverse function, right? So I'm just saying, hey, this is the original function. This just tells you, oh, now we're working with the inverse function. The reason why I didn't need an equation is because I was taking the coordinates and swapping them. Because there could be a case where you don't have a nice equation. There could be a case that your original function is like right? And there's no equation for that. So then I make a list of my points and then I swap them. So you don't need to write the equation. Yeah, is that good? A good answer? All right, let's go and graph these. So the original parabola follows a step pattern. And sometimes labeling it with the entire equation is a bit messy. So in these cases, you can just label it as f of x. And the inverse function, you would label it with f inverse x. But the labeling part is important. Team Wood, your question was very good because you basically got us started with the lesson. And so again, just notice I'm just going to label it f inverse x. And if I have colors, it just makes it so much more clear. You're like, oh yeah, the blue goes with the blue, the pink goes with the pink. How many invariant points do we have? Beautiful, good. Right, let's label them just so we don't forget what invariant points are. Different color, orange. Okay. Who forgot what an invariant point is? Okay, basically it's points that don't get affected by transformations or doing the inverse. Okay? I'm going to say don't get affected by transformations or the inverse. Basically, they stay the same. That's the point. So there's 2 points that stay the same. Did that help? Thank you. All right. So is the inverse, f inverse of x, a function? Why or why not? So is it?
Heck no.
No way, Jose. Why not?
Because it doesn't pass the VLT.
It failed. Not just that it doesn't pass, it actually fails the VLT. Boo! You get an F on your report card. I'm kidding. All right. Okay, so yeah, it's not a function, right? And we're like, at this point, what I love about you folks is that you are so oriented around functions that as soon as you draw this, you're like, something must be wrong. It's not a function. All right, so let's state the domain and range of the original and the inverse. We are building towards something. So for y equals f of x for the original, it's a parabola, right? That means x belongs to all real numbers, right? The x-axis is not restricted for a parabola, but the range is restricted, right? Because it goes above the x-axis. So y belongs to real numbers such that y is greater than or equal to 0. Go ahead and write the range and domain for the inverse. What did you notice, Liam?
I noticed that in the inverse of the function, that the y doesn't have a restriction, but the x does. But in the original, the x doesn't have a restriction and the y does, so it flips.
Bam! Just like everything else swaps. Beautiful.
That's super cool.
Isn't it? Is that sarcasm? I don't think so. I'm not even going to ask. Yeah, so what we're noticing is that once again, there's a swap. In this case, what is in the original function, the domain is unrestricted, and in the inverse, the range is unrestricted. Okay, and vice versa. Okay, so there is a swap, and even look at the fact that the x and y swaps, right? Okay, so here's the question. Can we take remember back to the learning goal?
Yep.
Restrict the domain of the original function. So can I restrict the domain of the original function so that when we generate the inverse is also a function? Tell me, Kajik.
If you restrict the domain and not letting it equal greater than or less than 0, like either way works, the range would be restricted.
So do I want to restrict this?
You can
Or do I want to restrict this one?
domain on the original.
Oh, domain on the original function. So Kajik is like, we got to restrict the domain on the original function. Anyone else have a sense of how to do it?
I think
He's on to something, right? This is what I want you to do. Forget the actual numbers and all that. Look at this picture, okay, and use your hand to restrict the function. Meaning you might be like, oh, I think we need to cut off this part of the function. Okay? Oh, no, I think we need to cut off these points of the function. So take this pink function and block out, Ilian, block out the part of the function that we don't want to exist. And then we're going to figure out how to restrict it. Okay? So that the blue ends up being a function. Right now, we're failing the VLT. How do I draw the original pink one so that I don't fail the VLT on the blue one? Do it with your hand. Show me. Any idea? You have an idea, Luke? Show me with your hand. How are you going to restrict it? You're not sure. Who has an idea of what we're doing?
Yes.
No? Can I say it in a confusing way? So, hey, if I want to get this pink, just this part. Which part of the blue is that? Think about that. So Sophie had a really good thought. Okay? So Sophie was covering this part of the blue function. She's like, in order to make the inverse a function, I need to get rid of this part. So then my question is, I was like, yeah, I agree. That's great. Right? If we don't have this bottom, or can I even stretch that, Julian? What if we blocked this instead? Does that work? Yeah, that does. So the question is this, Ilian. Dude, you're super chatty. I love it, but it makes it a bit difficult. The question is, if I block the bottom part of the inverse function, how did I make that happen? Did I cut out this part of the function? Or did I cut out the right part of the original function? And the way that I think of it, because I'm a visual person, do you remember in the Friday lesson I told you to fold your paper?
Yep.
Did you actually do it?
Yep.
Good. So do that. So if you are blocking this part, fold your paper, okay? And then tell me which part of the pink one are you cutting out? Okay, is it the right side or the left side? Like literally fold your paper.
Right side.
This one, Sebastian?
You cut out that side.
No.
When you
Because if I don't want this to appear, and remember, this is the axis. It's the diagonal axis. It means this will fold onto here. Does that make sense? So that means I want to keep the right side. I want to cut out the left side. So we can do that. Okay? So if we want how's this? So we could say keep right side of the parabola, right? So that means it would look like this. So in order to do that, we said I have to restrict the domain of the original function. Well, domain, we're saying x belongs to R, and now we're actually going to restrict it. We're going to say this parabola cannot span the entire x-axis. It's actually going to only span half of it. So what can I say? X
Is greater than or equal to 0.
That's right. Because it's in the positive part of the x-axis. So all the negative values of x are not included. So we have a function, but we've actually restricted the function so that only part of it shows up. But what if I want to keep the left side of the original function? So meaning like that. Don't say it out loud. Write down the domain of the original function with a restriction so that only the left side appears. Okay, don't say it out loud. No, that's fine. Yeah, but I didn't tell you not to. Okay, what is it? Is it greater than and equal to or less than and equal to? Less than, meaning all To get the left side of this one, that means I want all the negative values of the x included. Now what I want you to do is graph what the inverse will look like. Sorry, not graph, just draw a picture. And look up top, right? Is it going to be the top part or the bottom part? Imagine you're folding the paper, like literally, if you need to fold the paper, fold the paper. I hope my test gets a bunch of folds. Okay, so then you're like, okay. So if we keep the right side, we're going to get the top part. If we keep the left side, we're going to get the bottom part, right? So that they literally fold on top of each other if we're folding the paper on a diagonal. Questions? Is this kind of making sense? Okay. All right, let's do the exact same thing on the next page. All right. So it's literally the same thing. So what we have here is we have a restricted function, and your job is to figure out what restrictions were placed on the original function. Okay? So it's literally the same thing. Okay? So now I don't need the domain of the inverse. I just need the domain of the original function. Okay, so you're just filling in the blank for this.
It's like, we'll need to draw these functions like this in the test.
Oh, yeah. Yeah, this will definitely be included on the test. Drawing the inverse of a function. It might be even trickier. And you're like, that's fine.
I mean, not just in general inverse, but like...
Yes, the restricted. Absolutely.
The shapes.
The parabola? Yeah, it's a parabola. 1, 4, 9. All right, the first one, what is it? Greater or less than? Greater than and equal to 0. X is less than and equal to 0. Okay, before we get to homework, I do want to give you something, just show you how we do this when the vertex is not on the origin. So let's say the vertex is at, let's go in the negatives because we have space, -3, +2. Okay, so we've got a function that is x plus 3 squared minus 2. Oh, sorry, not minus 2, plus 2. Okay, so it goes up by the regular step pattern. So as you're looking at my function, I'll give you another. Do you need time to draw it? The vertex is at -3, +2. Is the inverse of this function going to be a function? Heck no. So what I want you to do is take your hand and block off one option of so restrict the function with your hand by cutting it off. Okay, so I could do this, or I could do this. How do you draw it? I'll show you in a second. The step pattern is 1, 3, 5. That's what I used. Okay, so now let's practice restricting this function, the domain of this function, because it's just going to look a bit different, right? So we've got two options. Restrict function. So we're always restricting the domain. Notice. Okay, we're not restricting the range. That won't help. So my question to you is, what number goes here, right? So if my vertex is at -3, 2, is it the -3 or is it the 2? It's the -3, right? Because it's on the x-axis. That's the x coordinate. So that's really the only difference. Does the y coordinate matter? No, not in this case. So we're just restricting it before and after the -3. All right? Okay, folks, you have 23 minutes to do your homework. You can also come up to me and ask me questions. Okay, please take